You're going to be practicing calculating diversity first by hand using a worksheet and then applying those same skills to putting that information into a spreadsheet to see if you can get the same answers, because both of them are necessary for biology, but both of them involve different skills, especially being able to type in formula. So I'm going to demonstrate how to do it on the easy spreadsheet, but there is also one that's a bit harder, the Rocky Shore one. First of all, I'm just going to go through it. You have different species, A to J. Okay, they could be birds, they could be mammals, they could be fish. You don't know what they are, but they're in 3 different areas, community 1, 2, and 3. Now, here you're going to be looking at the biodiversity of each of these communities so that you can then compare them. So let's just go over here to community 1 and we'll have a closer look. Now, still getting used to this new OneNote, but we'll get there. Okay, I've got sparkles here. First of all, when you look at any community, you need to know the total number of individuals that you have. Now, they've already given you the individuals for each species. So species A here has 10 individuals, species B has 9. So they've already given you the n value, the little n value, the number of individuals for each species. But what they haven't done is given you the individuals that are in the area total. In order to do that, you have to sum, or if you look in Excel, that's the symbol for sum up all of these values here. And if you add them up, you'll find that comes to 100. Now, the next thing you need for Simpson's diversity is to give it the fudge factor. So you also have to find out what n minus 1 equals. So 100 minus 1, I should put here, equals 100 minus 1 equals 99. So there's my next part of my formula. Now, I have to now go and find out what the fudge factor is for each of those individual species. So in this case here, for A, n minus 1 fudge factor, that's going to be equal to 10 minus 1, which is going to equal 9. And this one here is going to be 9 minus 1, which is going to equal 8, and so on and so forth. I think you get the picture there of how you would then calculate these ones down here. And then, of course, the last part of Simpson's diversity formula says that we need to square the values, including one of them having the fudge factor. So I essentially have to I'm going to change my pen here, take this guy, and we need to multiply them. Okay? So that's our n times n minus 1. So I'm going to have to do 10 times 9 equals 90. And I'm going to have to continue that down through here. So I'm just going to speed that up while I do that. So once I got them all down there, what I then did is I found the sum of all of those numbers by adding them up. Remember, in Excel especially, that's the symbol for sum. So I added all of them up. Now we're going to use that to calculate Simpson's diversity index. So diversity with Simpson's is 1 minus all of this. Okay, first of all, you take the sum, this is why I've been wanting you to remember the symbol there, the sum of all of those little n minus 1, okay, divided by the big N outside of big N minus 1 value. So that means, if I draw this here, get a little highlighter, this little guy here is this number here, and let's get a different color. Okay, this guy here, oops, I haven't done it yet. this guy here that I'm about to do will equal this number here. So let's work out that last one. My n times my n minus 1, this big one over here, is going to be 100 times 99, which is going to be 9900. Okay? So on my bottom here, I'm going to have 9900. My top, I'm going to have 912. Now that we've put that in, when you do a little bit more calculating, first of all I'm going to fill this out. So 1 minus that whole fraction. Well, let's put that into a calculator and find out what that is. That's going to be 1 minus 0. I don't even need that bracket there now. 0.0921, so on and so forth. If you work that out then, 1 minus that, it equals 0.90787, which really means we don't have a very high diversity at all, because we have a number that's very close to 1. And that's how you work out this Simpson's diversity complex by hand. Now, I'm also going to show you this on Excel. Here is that same problem in Excel, and we're just going to get Excel to do exactly what I did by hand, but make it do the hard stuff. So you're going to hear my my keys in the background, but don't worry about that. So essentially, I've got to tell Excel what I want to do. Now, the very first step was, I've got my count here of my species A, B, C, D. I need to know what that is minus 1. So this is going to equal, now you don't say 10 minus 1, that's just not going to help you. You need to tell it what cell. I'm going to go equals whatever is in this cell minus 1. And it's going to work it out for me. Then I'm going to say, okay, I want to take those two cells and multiply them together, just like I did on the OneNote. So just over here. Remember how we did this cell times this cell to get this number here, 90? Well, we're going to do that here, but I'm going to do it by cells. I'm going to go, so equals whatever's in this cell, my n, times by, now this is your shift star, the thing above the 8, times by whatever's in this cell. And see how it highlights them with the different colors so you can see you've got them right? And go equals. And it works out exactly what we had done before, 90. Now here's your trick if you don't know this one. You highlight those cells that now have the formulas in them, not just the type numbers, and you get it to copy those formulas down so you don't have to type them all. So you bring your little arrow over here till it turns into the cross and pull it down, and it will copy that formula to each one of those cells. Now I just need to add these up. I wanted to add or sum all of these guys here. So I'm going to use this little symbol up here or type in the word sum. So you can do either, but if you do this one here, it has all the ones that you usually use more than anything else. So the first thing is sum. And it'll go, oh, of what? What do you want me to add? And that's why it's waiting there with the brackets around it. You highlight all the cells you wanted to add up. And then go enter. And voila, 912, exactly like our spreadsheet, our handwritten note, sorry. Now over here, I needed to add up how many individuals are in the area, regardless of species. So this is going to equal the sum, and this time I'm going to type it because it's quicker, SUM, and then open brackets to tell it what it wants. I want to find the sum of all of these, close brackets. I don't even think you need to press close brackets, but I always do. Done. And it matches again what we'd added up by hand. Now I need to know what n minus 1 equals. Well, it's going to equal whatever is in this cell here my n value, big N value, sorry, minus 1. Done. 99. So now for the hard bit, actually typing it in. To get the diversity, we have to type in the formula, and we have to just be a little bit careful that we get it right. Because we've got to put everything in brackets to make it do it properly. So you always start with equals, and then it's going to be 1 minus everything in a bracket. So we're going to go 1 minus everything in this bracket. Now, remember, we wanted the sum of all our little n's and n minus 1's on the top. So we're going to click this cell here. And we needed him to be divided by, so that's your slash, our, oh, I forgot to do it again. Just a minute. Okay, let's get out of here. Where am I going to put this value? I'm going to put it right here, whatever's in H4. Close brackets, and you're going, oh, Mrs. Draper, what's this about? Remember how I forgot to do this before? We needed to find the n times the n minus 1 of the big N's. So this is going to equal this n times that n. Okay, and I might make sure I add this into your Excel spreadsheet. Equals. So there's my n times n minus 1 value. And now, there it is, because it was already in that formula, on there. And that amount there is exactly the same as we worked out by hand. And that is Simpson's diversity formula in a nutshell. Good luck. You're going to need to practice doing this until you get your head around it. You have answers to check along the way. Off you go.